Hello, and welcome to the Networking Fundamentals, Mastering the OSI Model and TCP IP in Under 1 Hour webinar, presented by our very own Ed Liberman. Hi, I'm Chris Graham, a product development specialist from TrainSignal, and I'd like to take a minute to tell you what you expect to hear in the next hour. The presentation will take approximately 50 minutes, after which we'll have an additional 10 minutes for a question and answer session. Please feel free to submit your questions in the questions box throughout the presentation. You don't have to wait until the end. Also, do use the question box if you have any technical difficulties during the presentation, and we'll do our best to assist you. Today's presentation will be recorded and will be available to view tomorrow at trainsignal.com/blog/webinars. Don't worry if you weren't able to get all that down. We will email you the information about how to view the recording after the presentation. Now, you will be prompted to take a short survey. TrainSignal wants to hear from you, so please take a few minutes to complete this survey. We will also have one participant from today's audience receive a copy of our Networking Fundamentals training. Now, in order to be eligible, though, to win, you need to fill out that quick survey that follows the presentation. If you have any additional comments or feedback, please feel free to send an email to webinars@trainsignal.com. With that, thank you for joining us today for today's webinar, and here's Ed.
Thanks, Chris, and welcome everybody. Glad to see you here today. So let me just turn over to my presentation real quick. And there we go. So we are here to learn about the OSI model, or at least that's what I'm here for. Hopefully that's what all of you are here for. In this webinar, what are we going to talk about? Well, we're going to start off by reviewing the definition of a protocol. Before we get into what the OSI model is, we have to know what the term protocol means. So we're going to talk about that. We'll then see how that relates to this thing called the OSI model. And then we're going to see how the OSI model relates to the TCP IP protocol suite, which in today's world is one of the, matter of fact, it is the most heavily used protocol out there, and the reason is because, well, we need it for internet, and since everything's on the internet, well, then we have TCP IP. Now, before we get into anything at all, I want to start off just right out the gates with a poll question for you. Okay, so let me go ahead and grab this poll question. So you're already going to have to do some work here, and I have a question for you. And that question is, have you seen any of my lessons before today? Now, before you answer, I want to clarify. I want to know if you have seen lessons from me, Ed Liberman. Not necessarily TrainSignal, but my lessons. And you'll see I have a few choices here. Network Plus, any of my Microsoft courses, any of the free lessons that I have out on trainsignal.com/blog, which formerly was trainsignaltraining.com, if you were familiar with it that way, or a previous webinar, or maybe you came and saw me live at a speaking engagement, or if you haven't seen me at all. So I want to see where my audience is as far as if you're familiar with me and my material. So go ahead and answer that now. All right, give this just a moment here. Looks like most of you have voted, so I'm going to go ahead and close this poll so we can see where we're at. And it looks like 3/4 of you, a little more than 3/4 of you, have not seen anything from me before. So you know, I'm not sure what to tell you. You're either in for a real treat or an hour of misery. I'm not sure. And for the rest of you, looks like there's a pretty evenly divided spread between seeing Network Plus, Microsoft, some of the free lessons that I have out there, and even a couple of you, or a couple percent anyway, look like you've been to my webinars or speaking engagements before. And the reason I wanted to ask that question is because this material that we're going to cover today is also covered, or a version of it is also covered in some of my previous courses. And so I wanted to see if you've seen this material before. So let me go ahead and close this, and let's get ourselves back to the presentation. And since most of you have not been with me before, let me just give you a brief introduction to who I am. My name is Ed Liberman. I've worked in technology for over 20 years now. More importantly, I've been certified in instructing IT professionals for, let's see, it says 13 years. I'm trying to figure out, I think we're close to 13 and a half years now if I go back to the anniversary. You see I got quite a bit of alphabet soup behind my name, all those MCT, MCP, all that fun stuff. It just means I've taken a lot of certification exams. To tell you a little bit about who I am just as a person, though, is really what I think is more important. And that's why I have on here about how I volunteer my time, my local community, as a math tutor for struggling grade school children. And that tells you that who I am. I'm the kind of guy that enjoys and finds enjoyment in helping others. And that's why I do what I do. We all have to work, and we all have to bring home a paycheck. But where I get my enjoyment is helping people, making a difference. And there's nothing more pleasurable to me than seeing a child who's struggling, and I can turn that around and suddenly see them smiling about what they're learning. And I hope I can do the same thing for some of you here today. In fact, I hope I can do it for all of you here today. But that's really where I get my excitement from. And I would even say to all of you, I hope that you can find what you really enjoy out of life and then go find a way to make that part of your career as well. And that's one of the things I love about the IT profession is no matter what it is that you enjoy doing, in some way, shape, or form, you should be able to relate it to the IT profession. Beyond that, I am the lead Windows Server instructor here at TrainSignal. Okay, so that's what I do to earn my paycheck right now. So that's kind of the brief, quick, who am I? Now with that, guess what? I'm going to bring this back to you guys. And the reason I'm doing this is I want to get you guys used to participating in this. For the few of you who have seen my material before, and if you start watching as we're going through here and it's looking familiar, I want you to still feel like you can get something out of this. And the one thing that you can get is participation, asking questions that maybe you had that I couldn't answer when you were just watching on a DVD and I wasn't there. Okay, so that's an opportunity for you. So let me go ahead and jump over and get you involved with another poll. And I already found out how many of you had seen my material before, but now I want to know, where are you? Where in the world are you? I apologize that I can only give 5 choices here. That's why Asia, Africa, and Antarctica are all clustered together as one. And I will apologize in advance just because I know I had somebody bring something up in the past that I have Australia and they were from New Zealand. So if anyone here is from New Zealand, these are continents that I'm referring to, not countries. So please don't be offended by that. And so looking at the poll here, I'll close this in just a moment, but it looks like most everybody is from North America. I'm going to go ahead and close this now. I'll let all of you see that looks like 3/4 of you are from North America. Maybe that's the same 3/4 who have never been with me before. Maybe the only people who have seen me before who are here are from the other continents of the world. I see 7% from Europe and another 16% from Asia, Africa, and I wonder if any of that 16% is from Antarctica. I think that would be very cool. All right, so I have one more poll for you, and this just gives me an idea of who you all are, since we can't all talk during this thing. And I just want to know, how familiar are you with the OSI model? Okay, how familiar are you coming into today? I never heard of it before. You heard of it but don't really know what it is. You learned about it but still don't seem to get it. Or, maybe you completely understand it and just have nothing better to do today. And I'm actually getting a good laugh out of this because I know you guys can't see it yet, but either you guys have a really good sense of humor or 20+% of you completely get the OSI model and just had nothing better to do today. So anyway, please go ahead and get your answer in here, and then I'm going to actually explain to you where this lesson came from, because it really came from this question right here. All right, so I'm going to give you just maybe about a few more seconds, get your answers in. Looks like pretty much most everybody has voted. So let's go ahead and close this, and let's take a look. All right, so 70% of you learned about it but still don't get it, meaning you've heard about the OSI model, you've read it in a book, you've gone to a class, a seminar, whatever, but you still just don't get it. And that right there is where this presentation came from. Somebody asked me, they threw it up in the question box before the webinar started as to whether this was going to be a 101 level presentation, and my answer was, yeah, pretty much. It's going to be a 100 to 200 level presentation, and the reason is because what my goal is to accomplish here today is to take this thing that 70% of you have heard about already. Somebody else has already tried to teach it to you, but you still just don't get it, and I'm going to hopefully help you to get it. That's something that I've worked on very hard over the years, and I've had many people come up to me after this presentation and have said, you know, I've heard about it many other times, but now I finally get it. So I hope I can do that for you as well. I do have to say I find it very interesting that 23% of you totally get the OSI model, and you just have nothing better to do today than to sit here and hang out with me. So thanks for being here. I love that. I don't know if you're being funny or not, but you know, the more the merrier, and even if it means you want to throw out questions that maybe will help others, I think that's great too. I think that's one of the benefits to this type of an opportunity is somebody else will ask a question that you were thinking of, or maybe you didn't think of, but you do want to know the answer to. Okay, so like I said, I did all that because I needed to learn a little bit about you, but also because I want you involved. Okay, webinars are an interesting thing in the sense that it's all me talking to you, but I want this to be mutual involvement. What you can do from this point forward is ask questions as they come up. I'm going to actually make an attempt at answering some questions when we get about halfway through this webinar, and then just as Chris stated, I'm going to answer the rest when we get to the end. Okay, so moving forward, let's start off with a protocol. What is a protocol? Well, a protocol is a set of rules and procedures used for communication. Okay, just to put a real simple definition on it, it's a set of rules and procedures for communication. You could look it up in the dictionary and you'd find something similar to that. And there's many definitions of it, but that's one of them. What I want to start off doing is try to put an explanation behind what do we mean by rules and procedures for communication. And the example that I like to use is if you wanted to mail a letter, right? You got a letter, you want to send it to a friend. I mean, today, and I don't know if this is celebrated throughout the world, I think it is, but today is Valentine's Day. And so there's a lot of Valentines being sent. So let's say you wanted to send a Valentine, and you wanted to use, at least here in America, the United States Postal Service to mail that letter. Well, then you have to follow the United States Postal Service protocol. And the first step in that protocol is you have to take your letter, or you have to take that Valentine, and you have to have some kind of packaging. You have to put it in an envelope that's appropriate. Okay, so that's step one. Then from there, you have to put an address of who you're sending it to onto the envelope. Okay, so we're going to say that that's the destination address. And believe it or not, that address, even though I'm going through the protocol here, right? This is the United States Postal Service protocol. Each of these individual steps have their own set of rules and procedures, right? In other words, not only do you have to put a destination address, but you have to put it in a specific location on the envelope, and it has to be formatted a certain way to where you put the name and the street number and the street name and the suffix. Okay, you have to do everything in a certain way. So that's like a little mini protocol within the bigger protocol, and we'll see how that is what makes up what's called a protocol suite. We'll talk about that a little bit more later. So once we put a destination address on, well, we also need to put a source address, or in the case of mailing a letter, it would be called the return address. And again, it has to be in a certain location on the envelope, formatted a certain way. Then we have to pay the United States Postal Service, right? And we do that by putting a stamp of a certain value based upon the weight of the package, and we have to put it on a certain place on the envelope. And then we have to have a way of getting it onto the United States Postal Service network, right? So we can give it to our mail carrier, or we can put it in a public mailbox, or we can go to the post office. There's a lot of different ways we can do it, but you have to have a way of getting it out onto the United States Postal Service network. And if you follow all those rules and procedures as have been established by the United States Postal Service, then your Valentine will get to your loved one. All right? So that's what we mean by a protocol. Now, just to make sure, if you're still not clear, I'm going to take this one step further. Now, let's say we wanted to send it FedEx. All right? Maybe we want to use FedEx to send our Valentine. Well, you still have to put an appropriate type of packaging, right? There's a FedEx letter envelope that you're supposed to put it in. You still have a source and a destination address that you fill out, but you'll notice it's a little bit different, right? You put it on a form, and there's different information that's needed. You still have to pay with either a FedEx account, or you can pay in cash when you actually go to the station, and you still have to have a way of getting it out on the FedEx network. Okay, so although the rules are slightly different, we still have a protocol that we have to follow if we want to send it via FedEx. Now, on a computer network, the computers that want to talk to one another, they have to agree upon a common protocol in order to communicate. So here I have an example of what if we send something FedEx with the destination of a United States Postal Service P.O. box. Can't do it. And I know some of you might already be aware there are ways to get around this, and we'll talk about that in a whole nother world, whole nother webinar. But by definition, by default, with FedEx, you must put an actual street address, okay? Because you're crossing protocols is what you're doing here. So, if we put this all together, again, remember, if we want to mail a letter with the United States Postal Service, we have to follow their protocol. If we want to send it FedEx, you have to use their protocol. But what did they both have in common? They both had the same standards, the same minimal requirements, right? We still had to have a destination and a source address. It may have been a little different on how we did it, but we had to have it. There had to be some kind of packaging. There had to be payment. There had to be a way of getting it on the network. The specifics are different, but the minimum requirements are still there. And I could have continued this example using UPS or DHL or whoever your favorite carrier is. And I apologize, but the screen, it looks like, although it was up on my screen, I'm just looking, it looks like it just came up on your screen. So that whole time when I was giving you those examples, here they are. Packaging, addressing, payment, and getting the package out on the network. So how does this all relate to the OSI model? Well, back in the 1970s, the International Standards Organization, and by the way, that's not their official name. I believe it's International Organization of Standards. But anyway, many people commonly refer to them as the International Standards Organization. Why? Because their letters are ISO. So not completely technically accurate the way I have it in front of you, but the way it's commonly known. And who are these people? Who is these standards people? There are a bunch of geeks and engineers that sit around and decide this stuff for us. That's the easy way to put it. And if you've ever had courses with me, you know that I use that a lot. I use that when talking about this or the IEEE or all sorts of different organizations that put these standards together. Well, what they did was they developed this thing called the Open Systems Interconnection Reference Model, or the OSI model, to define the basic standards for network communication. So what is the OSI model? The OSI model is those basic standards. It's the equivalent of when talking about mailing a letter, knowing that we have to have addressing and packaging and payment and a way to get it on the network. Okay, this is those same standards, but for computer networking. So any and all other networking protocols that are in use, well, they are all derived originally from the OSI model. And not to get ahead of myself, but that's why at the end of this we're going to talk about TCP/IP, because that is a specific protocol suite, but we'll see how it ties into this OSI model. So now let's learn the OSI model. And here's the thing. When 70% of you say that you've learned it but you still don't get it, part of why you might not get it is because you might be overthinking it, or you're trying to understand it too much. And so what I'm here to do today is to give you something that is going to allow you to know enough about the OSI model to go out and be a successful network administrator. Now, if you want to get into a career, or if you're in a career where you're truly designing networking components, you're actually creating the chips that allow networking to take place, you're going to need to know more than I have here. And that's why I say, yes, this is going to be a 1 to 200 level presentation. My concern is that so many people, they just go through, they read it in a book, or they go through class, and they don't understand it at all. So the very first thing you need to know is that the OSI model is made up of 7 layers. Okay, 7 layers to the OSI model. And I have them listed on the screen from top to bottom. And it's important, by the way, that you know these from top to bottom. They are application, presentation, session, transport, network, data link, and physical. You can memorize that, right? That's not that hard. Well, you know what? It is pretty hard. Memorizing 7 random words is not easy. So we're going to have a little fun with this. And I'm going to guess that many of you have done this already. I mean, if you've already learned about it previously, almost every book I've read, almost every class I've gone to does this in some way, shape, or form. And that is, you just take the first letters of the 7 layers, the A, P, S, T, N, D, P, and we go ahead and come up with some kind of a saying that makes sense to us with those letters. And one of the originals, and one of the, still today, one of the most commonly used, is all people seem to need data processing. Now, is that easy for you to remember? All people seem to need data processing. I don't know. I didn't find that saying to be too easy when I first learned it. So let's go with another one. Let's go from the bottom up. So look, read this backwards. Read it from the bottom up. Please do not throw sausage pizza away. I actually saw somebody mentioned me out on Twitter, along with I don't have the exact tweet in front of me, but something about, you know, OSI. Suddenly I had this craving for sausage pizza or something like that, and I'm sure this is why it was mentioned, is because in any OSI model lesson, there always seems to be some way, shape, or form sausage pizza included in one of these sayings. So please do not throw sausage pizza away. But maybe those two aren't even, you know, acceptable to you. Great. Here's a few additional. And you can find a whole bunch more. But, I mean, here's a priest saw 2 nuns doing push-ups. That's, I know Chris, who introduced you all to this webinar, that's his favorite. That's the one that he remembers the OSI model with. And we have all people should try new Diet Pepsi. You know, I was just thinking I should probably see if they'll pay me for a plug since I threw that in there. Please do not take salespeople's advice, or please do not tease stupid party animals. The point is, I don't care what saying you use. Find something that makes sense to you with these 7 letters. And then, with just a little bit of practice and a little bit of studying and a little bit of understanding of what actually happens, you'll get the 7 layers of the OSI model, and you'll get them in order. Okay, and I will tell you, that is step 1. Okay, and I really need to emphasize, you got to take this one step at a time. That's the big problem why people don't get the OSI model. They're trying to learn everything instead of just one step at a time. Now, what I have on the screen right now is something that I created, and I can't even take full credit because one of my instructors, who then became one of my peers, many years ago. He played a big role in the idea behind what you see in front of you. And what you see in front of you is what I call my one-page cheat sheet to everything you need to know about the OSI model. And I will say, really, when I say, is this everything you need to know? It's everything you need to know for the certification exam. Okay, we could say that. Okay, so for a certification exam, this is everything. This has everything you should be challenged on. Now, let's see how this is all put together. First thing we need to do is break this down to simple OSI model and what takes place at each of the 7 layers. Okay, just what are these 7 layers and what takes place? And this is probably the part that is most difficult for most people trying to learn the OSI model. And the reason why is because every single book you read, every single class you take, every single webinar you attend, every single person you answer, they're going to have a slightly different answer to what happens at each of these layers. And there's nothing that says, by the way, that what I'm about to tell you is any more correct than what anybody else has told you. So what I'm going to challenge you with is don't overcomplicate this. Okay, just don't overcomplicate this. These are very, very broad strokes, very generic here. And that's why I have simple 1 or 2 word definitions, and keep it at that. The top layer, starting at the top, application, deals with network APIs, application programming interfaces. The application layer is pretty much the interface between your applications and operating system and this OSI model and what's eventually going to be the network. So I used to explain it as a network API is kind of like an application saying, hey, I have something I need to send out on the network. Or if it's on the receiving end, hey, there's something coming in from the network. Okay, it's that interface that communicates with your application. And I mean literal applications, like things that you use, you the human. The presentation layer deals with the formatting of the information that's going out on the network. So what format is the data going to be in? The session layer, now the session layer has kind of changed over the years as to the strongest opinion. This is actually my original one-page cheat sheet where I've always had synchronization. There still is a form of synchronization that does take place at the session layer, so getting the sending and the receiving computer in sync with one another. The transport layer, I have packets, or sometimes I'll write a 2-word definition that says packet management. Data, when it is sent, is broken into packets, and the transport layer manages those packets. Okay, it manages the keeping track of how many there are and did they all get there. The network layer deals with addressing and routing. Okay, so when we get to TCP/IP, and not in this webinar, but if you were to get deeper into TCP/IP, you learn about IP addressing. Okay, so that's the type of addressing that we're referring to, and then with those IP addresses, we also can then route data from one network to another. The data link layer deals with data frames, and this is an interesting one because if you were to look up the definition of data frame and look up the definition of packet, you'd find that those terms are interchangeable in many instances. So it's like, well, wait a minute. The transport layer is packet management, and the data link layer is data frame management. What's the difference? When we say data frame management, we're talking about the actual packaging would be the best way to put it. Putting it in the appropriate envelope is the best analogy that I can use. Okay, so whether it's going to be an Ethernet frame or a token ring frame, that kind of a thing. What type of network are we packaging this to go out onto? What kind of envelope do we need? And then the physical layer is easy. It's all about the hardware. Okay, how is the network card attached to the cable? Okay, that's physical layer. That's why I say when we go back up to the top, network APIs, you know, that's the interface between the application and the OSI model. And I said, and then eventually the actual network. Well, it's all the way down at the bottom of this OSI model. We're now actually physically connected to the network. Now, don't worry. That'll make a little more sense as I go through the rest of this one-page cheat sheet. So let's actually address this right now, this whole top-to-bottom thing. What I've done is I've added a second computer, right? I've added a second OSI model is what I've done, and then I've also added 2 computers. And you'll notice at the top of the left one, it says sending computer, and on top of the right one, it says receiving computer. And that is significant. And the reason it's significant is because you'll notice that the arrows go down through the OSI model on the sending side, and they go up through the OSI model on the receiving side. That is important to know. That is not a trivial piece of information. That is a significant piece of information. When a computer has information it needs to send, it goes to the application layer with the network API and says, I have something to send. And really, I should say when the application does or when the operating system does. It then goes down through the OSI model, and the presentation layer decides how to format, and the session layer puts some synchronization information, and the transport puts some packet management information. Network layer deals with the address and how to route to the other computer. The data link layer makes sure it gets in the right envelope. And then the physical layer does what? It puts it out on the network cable. That's why I drew a cable down at the bottom. It puts it out on the network. It goes across the cable, and then on the receiving computer end, it goes back up through the OSI model, starting down at the physical layer with it coming off the cable. And then each of the 7 layers will then acknowledge what the corresponding layer on the sending side added to the information. Okay, so that's why I have those dotted lines going across. It's because virtually the OSI model is talking straight across. There's no up and down. Up and down is how the data travels in transmission, but the dotted lines represent that the transport layer talks to the transport layer. They don't care what the other layers have to say about this. And I'll tell you what, I have an illustration here. I hope this works through the webinar because I know there's a slight delay, so I'm going to do my best to hopefully have this come through. But let's say the sending computer has some raw data, right? Just has some data it wants to send. All right? This is where there's an animation here. I hope this works. What happens is it goes down through the OSI model, and it should hopefully start going. I'm looking at, yeah, see, it's not actually working. Some of you may have seen some of the animation, but what happened is as it goes down through each of the 7 layers, there is some information that is appended to the front or the back, or what's known as a header or a trailer, of the data. So that when it gets down to the physical layer, and that's what you can see right now, all those slices of information have been added. Then from there, and again, you're not going to see the animation like I do, it travels across the cable. And then on the receiving end, and again, I hope you guys can see at least some of this animation, each layer, as it goes up through the OSI model, and I'm just going to start it going, each layer is stripping off what the corresponding layer from the sending side had put on. Okay, so again, I don't know if you could see the full animation. I hope you actually could, because it really emphasizes what's going on here. How each layer is adding a little information, and then when it gets to the other side, the corresponding layer strips off and acknowledges that information, so that when it gets all the way up through the OSI model on the receiving side, you're just left with raw data, which is what you started with on the sending side. And by the way, I do see a couple people have posted that you saw it perfectly, so that's great. I hope you did. Like I said, it was hard for me to tell on my end if there was delayed or not. So what do we have right now? We have the 7 layers of the OSI model. We have to know their names and the order: application, presentation, session, transport, network, data link, and physical. We have to know what takes place at each of these 7 layers. And I've given you, again, just quick 1 or 2 word definitions just to keep it real vague. And that's on purpose. You don't want to know specifically because it's not going to be that specific in the real world. And when dealing with another protocol suite, it's going to be slightly changed from there anyway. And we know how data travels through the OSI model and how communication takes place. So we have one last piece to this cheat sheet, and that is knowing certain hardware devices and where those devices operate within the OSI model. And again, this is my original cheat sheet, so it's a little out of date. I'll explain where it is. But the physical layer is where you have things like hubs and repeaters. Now, these are old devices that you don't see used that often in today's world. And the reason why is because, well, there's not a lot of sophistication to a hub or a repeater. These are devices that are responsible for doing nothing more than basically hearing the transmission, or hearing it, seeing it, however you want to think of it. We'll say receiving the transmission, and then retransmitting it. No filtering, no brains in it. It just says, oh, here's the transmission. All right, let me send it back out. A repeater would be for the purpose of sending it further, and a hub for the purpose of sending it on further and to multiple computers. A bridge, or in today's world, more likely would be a switch. And for those of you that have knowledge of this, I know that there are multi-layer switches. But by basic definition, the original switch had functionality at the data link layer. And the reason why is because a switch does filtering. It's just like a hub, but it does filtering. And it does filtering based upon a computer's MAC address, the actual physical hardware address. And how does that tie into the data link layer? Well, if we wanted to go into the slightly more advanced version of this presentation, we would know that the data link layer is actually split. It's been further split into 2 sub-layers called logical link control and media access control. And media access control, otherwise known as MAC, is where the name MAC address comes from. Okay, so that's why we're saying that bridges and switches function at the data link layer. Routers, which deal with routing, seems fairly obvious, function at the network layer, because what does network layer do? Routing. And the last device I have listed here is a gateway. And a gateway, although I have it listed up top at application layer, the reality is that a gateway can have functionality at any and all of the 7 layers of the OSI model based upon what type of gateway it is. Now, let's talk about what a gateway is. A gateway is just to make it real simple, it's a protocol translator. Now, don't mistake this with default gateway. A default gateway on a computer is a router. Okay, that's the IP address to your router. We're talking about a gateway, which is a protocol translator. It's a way of making it that one computer can talk in one protocol and another computer can receive in another protocol, and they can communicate because they have the gateway, the translator in between. Most of these translations do end up taking place high up. They are high-level protocol gateways. All right, again, let's not over-confuse this. Okay, the idea here is keep this simple. Don't overthink it. What you see in front of you right now is everything you should need to know to pass the Network Plus exam, any Microsoft certification exam, and I welcome any and all of you to please communicate with me if you find that they're getting more advanced with these questions, because they shouldn't be. If anything, they should be eliminating these questions, because this is information that is not as vital as it used to be in years past. All right, I'd like to take a moment here to step away from the presentation and see if I can't answer a few questions. Let's see here. What is the meaning of layer 3 level VPN router? Okay, well, a level or layer 3, and let me actually, I'm tell you what, I'm going to take my screen and I'm going to put it back a second. One thing I didn't mention to you is the OSI model. You have to know the order of these layers, but you also need to know that they are numbered from the bottom up, meaning the physical layer is layer 1, data link is layer 2, all the way up to application layer 7. So what that means is the meaning of a layer 3 level VPN router means that it is going to have functionality at the network layer, meaning it's truly a router. Where you typically see layer 2, layer 3, and things like that, usually that has to do with switches. When you're dealing with a switch, which by definition, here I said it was a layer 2 switch, there are switches that can give you VLAN capabilities and things like that, which also include layer 3 functionality. Okay, another question I have here is, the OSI model seems ideal. When computer networking, are all levels of the OSI model used, or do some levels get skipped or blended together? Yes, they definitely do get, not so much skipped, but they do get blended together. I could give you an example where they are skipped. There was a networking protocol, which you don't really see anymore. This was back in the 90s. Back in the 1990s, there was a networking protocol created by Microsoft, I believe it was Microsoft, called NetBEUI. And NetBEUI, by definition, was a small, fast, easy to manage, non-routable protocol. And the reason it was a non-routable protocol, meaning you could not route from one network to another, you could only communicate on a single network, is because it was a 6-layer protocol. It was literally 6 layers to that protocol suite called NetBEUI. Application, presentation, session, transport, data link, and physical, meaning I skipped the network layer. So that's where it gets left out. Do they merge? Do they ever merge? Yes, and we're going to see that with the TCP/IP protocol coming up here in just a few moments. What exactly session layer added to the OSI model? I'm not sure exactly what you're asking as far as what you mean by what exactly was added to the OSI model. If you're talking about session layer as far as synchronization, what I mean by that, where it's used, again, there's a lot of gray area here in how the session layer was used with NetBIOS was another protocol, as opposed to how it's used with TCP/IP, a little bit different. The synchronization I'm referring to is some protocols work in a timing pattern so that you can keep in sync with one another. Okay, so that would be one example of what I mean by synchronization. It's hard to put a literal example on it, especially since the OSI model is not actually used for most communications. This is nothing more than a set of standards. Now, what I would say is when I get to the TCP/IP protocol suite, let's see if we can relate any of this. At which layer network card means NIC standard? Okay, so at what layer is the network interface card? That would be the physical layer. And actually, I should correct myself. It's physical and data link, or at least the bottom half of data link. Because remember, the data link is divided into LLC, logical link control, and MAC, media access control. And the MAC address on a network card comes from that media access control sublayer of the data link layer. But it's primarily the physical layer and a little bit of the data link layer. Would the physical layer also include the network NIC card? Oh, same question. Basically, yes. The physical layer definitely includes the network card. That's really, what that layer is all about. One more question. This is the last question. I'm going to jump back to the presentation. On which layer does a SAN, so a storage area network, switch lie? Well, again, it comes down to specific makes and models, and it comes down to exactly what that switch is doing. And that's why I feel it's so important to have just that basic functionality understanding of these layers, because if the switch is actually creating a VLAN, if it's actually doing some routing, then it's going to be a layer 3. And if it is not, then it's only going to be layer 2. And then I'm going to take it a step further and say, you know, there are devices out there that'll have a name like a switch, and it's not a switch at all, meaning that's just a name they tie to it. You got to look at the functionality. If the functionality has to do with certain TCP/IP protocols that we're going to look at here in just a moment, you know, then that's your answer. You know, then it's whatever layer that's at. So I think some of these questions are going to become a little more clear, I hope anyway, once we go through the TCP/IP model. So let's take a look at that right now. And then I'm going to, by the way, this TCP/IP model, we don't need to spend more than about 5 minutes or so going through this. It's not that big a thing. It's just seeing how it relates to the OSI model. And then I'm going to come right back and answer some more questions. So the TCP/IP protocol suite. And by the way, the analogy I'll use is the TCP/IP protocol suite is just like the United States Postal Service suite or the FedEx suite. Okay, it's a suite of protocols, but then each of those protocols have, you know, their own protocols, and you end up with an entire suite or stack of protocols. So TCP/IP stands for Transmission Control Protocol Internet Protocol. It's the basic communication protocol of the Internet. And although it was designed to be an Internet protocol, it can also be used to be a and not only can it be, but it is used as a communication protocol in a private network. Okay, so that's the kind of the point. It was designed for the Internet, but TCP/IP is everywhere now. The TCP/IP architecture is based off the 4-layer DARPA model. Okay, so the question about, you know, do the layers of the OSI model ever get merged and deleted? Well, here's a perfect example. It's a 4-layer model, and each one of those 4 layers will correspond to one or more layers of the 7-layer OSI model. Each of the 4 layers have individual protocols, and that's what I was just saying at the beginning here, is that's what makes this a protocol stack. So let's look at this DARPA model. It's 4 layers: application, transport, internet, network access. And I'll tell you what, I don't have some kind of nifty little saying to help you remember them. It's only 4 layers. You're just going to have to remember them. But more importantly, how do they relate to the OSI model? Well, the application layer relates roughly to the top 3 layers of the OSI model. So in TCP/IP, everything that's being done, the actual network application programming interface, the formatting, synchronization, any of that needs to be done, it's all being done now in a single layer. And to that question that was asked of me about explaining the session layer a little bit more, I'll tell you what, the session layer, I'm not going to say it's not important, but it kind of became a little bit less important based upon how certain protocols were formatted. And so that's why it's probably hard for you to truly grasp onto, well, what do you mean? What really happens there? Is because, you know what, in some protocols, essentially nothing happens there. Moving on to the next layer, we have transport. This is the easiest one, I think, to learn, and that's because, well, transport maps with transport. Done. Easy, right? The second easiest one would be the internet layer. And the internet layer, well, it maps almost perfectly evenly with the network layer. And then we have the network access layer, which maps roughly to the bottom 2 layers. So that's how they map out. And again, you have the same process. You have the same flow where if you have 2 computers, you start with data, it goes down the one model, and stuff is added on, and then you go up on the receiving end, and stuff is stripped off. And then we have our individual protocols, and it's these protocols that make up the protocol stack. Now, up at the application layer, you'll see the high-level protocols. We have things like HTTP for web browsing, and FTP for transferring files, SMTP for email, DNS for name resolution, RIP, SNMP, and I'll tell you what, that's not an all-inclusive list. There's a lot of protocols up at that application layer. The idea is these are the protocols that specifically tie to some kind of functionality that you're aware of within your operating system. Now I'm also going to skip real quick here to the bottom. We're going to go right down to the bottom layer. That's where you have things like Ethernet or token ring. Okay, if you're communicating on an Ethernet network or a token ring network. So that's just how the actual packet, the actual data frame will be encapsulated. And then, of course, how it's sent out on the network. That's the one other piece that's not here. What I want to focus on real quick with you, though, is the 6 protocols that you find in the middle. The transport layer protocols, TCP and UDP, and the internet layer protocols, IP, ARP, ICMP, and IGMP. These are really what make up the true functionality of how this model works. First, let's look at the transport layer protocols. We have TCP, which stands for Transmission Control Protocol. When TCP is used, it is a one-to-one communication, and it is what's known as connection-oriented. And because it is connection-oriented, it is considered to be reliable. Now, the big question I always get here is, what the heck does connection-oriented mean? That's the big confusion for most people. So let's talk about that. What makes it connection-oriented? It means that a connection must be established first before we can start exchanging data. So I don't get to just say something and hope you hear it. I have to say, hey, you, I want to talk to you. Let's make sure we're in sync here, and I'm going to send you some information. And the way it does this is with something called a three-way handshake. And the three-way handshake works like this. We have the first computer who says, hi, I'd like to talk. And here is the information you will need to communicate with me. Step 2 in the three-way handshake is the other computer then says, hey, thanks, I got your information. Now here's the information you need to talk with me. And then part 3 is the original computer says, great, I got your information now, so let's start talking. Okay, that's the establishing of a connection. It's the two computers agreeing with each other, okay, we have everything we need to communicate successfully with one another, so let's go. But there is another way to communicate with TCP/IP, and that is with a transport layer protocol called UDP, the User Datagram Protocol. This is what's known as connectionless and therefore potentially unreliable communications. This is where if I have something to say, I'm just going to say it and hope you heard it. This is very common in a multicast type broadcast. Matter of fact, what we're looking at right now, this webinar, I'm transmitting it, right? This information is just being put out there. It's being streamed out on the internet, and hopefully you're getting it. That's using UDP. I'm not establishing a specific connection necessarily with each one of you. I'm not getting a confirmation from each one of you if you've received every word that's come out of my mouth or every item on the screen. The audio in this presentation may have skipped somewhere along the way. I won't know. I just keep talking. That's UDP communication. And it's most commonly used in a multicast where one person is broadcasting or one computer is broadcasting and there are many listeners. Now let's move to the internet layer protocols. And I'm just looking at the time real fast here. It looks like we're a few minutes over where we're supposed to be, so we're going to wrap this up in a few minutes. We'll get back to your questions. The internet layer protocols. We have IP. Real simple. What does IP have to do with? IP addresses. With an IP address, we know how to address a package and then route it to its destination. But the reality is that once you get onto a network with its destination, you don't actually deliver it based upon the IP address. You deliver it based upon the MAC address or the physical hardware address. And the way that is resolved is with a protocol called ARP, the Address Resolution Protocol, which resolves that IP address down to the MAC address, down to that physical hardware address. We have something called ICMP, the Internet Control Message Protocol, which is used for diagnostic and error reporting. It is something that is used to attempt to make TCP/IP more reliable, but does not definitively make it more reliable, because ICMP is actually used with UDP, connectionless communication. the best analogy I could use is, let's say I send a letter to a friend, and that friend has moved, so it's a bad address that I'm sending it to. The post office is going to put a stamp on the envelope saying return to sender, and then attempt to send it back to my address, the return address. But there's no guarantee it's ever going to make it back to me. It could get lost in transmission. And that can happen with TCP/IP as well. But that's what ICMP is used for. And then IGMP, the number one thing I always tell people to know about IGMP is that it's not ICMP. It looks very similar. The letters are the same other than the C and the G. And the C and the G look a lot alike. But IGMP is Internet Group Management Protocol, and it has to do with the management of multicast transmissions. You know, like the one we're on right now. So that brings us to the end of the actual content, where we learned that a protocol is a set of rules and procedures for communication. And with those rules and procedures, we can have variations, but there has to be a standard that all protocols follow. And that's where the OSI model comes in. It's that standard that's been set for rules and procedures for communication for all protocols. And we saw the OSI model one-page cheat sheet. That was kind of the idea of what I was building here to hopefully, especially for the 70% of you, I feel like I've been picking on the other 30%, or not picking on them, but neglecting them. Those are for everybody, but primarily that 70% who maybe didn't get it before. Hopefully you get it a little bit more now, because hopefully I've simplified it enough for you, because I don't want you to overcomplicate it. I don't want you to feel like, man, he didn't tell me nothing. That was just the most generic thing. No. This is intentionally generic. It's intentionally generic to allow your brain to absorb it. And then we saw how we could tie that in then to the TCP/IP protocol suite. So let me jump back. I see that there are a few more questions out there. I'd like to address those questions, and then we will wrap this thing up and bring it to a close. So let's see here. Is it good to learn some tool like Wireshark to get better feel of OSI or the DARPA model? Yeah, that's not a bad idea. Wireshark, or even Microsoft's Netmon, their network monitoring tool, is a great way to start to put something tangible onto this OSI model. Because that's a bit. In fact, I have to say, I'm really, really glad that you asked that question, because this is something I usually bring up in this presentation, and I failed to. So I gotta send this guy some money. But basically, one of the problems that people have with this OSI model is, and this includes me, and when I say some people, this includes me, there's nothing real tangible about it. There's nothing you can reach out and touch. There's so much gray area, so much concept. How do I wrap my brain around that? Yeah, I think a network sniffer, a network monitoring tool like Wireshark is a great way to try to put something tangible onto the OSI model. Because what's going to happen is, what Wireshark's going to do is, you're going to be able to see the intimate details of all transmissions taking place on your network, and it's going to tie those transmissions to what they're related to. And in some cases, you can almost directly, or just plain directly, see it tied to the OSI model. TCP, let's see, TCP is like first-class mail with a tracking number, and UDP is more like regular mail. TCP gets acknowledgments, and UDP does not. Sort of. I've heard a lot of analogies like that. And I'm not saying that that's wrong by any stretch. I will give the example that I like to use. I like to use not just that it's like first-class mail, because if I mail a first-class letter to you, I don't know that you got it. But if I send certified mail, where you have to actually sign for it and then something comes back to me saying, yes, it was delivered, that is what I think of TCP. Whereas UDP is like regular first-class mail, where you just put it in the mailbox and you hope it gets there. But great way to think about it and put an analogy on it. Can you give another example of the model in use, like FTP app or even just web browsing? Okay, well, again, with web browsing, that's where you're going to have HTTP obviously used up at the top at the application layer, and then from there, web browsing itself is going to be more of a TCP because it's a one-to-one relationship between the client that's accessing the web server and then the web server itself. From there, you're obviously using IP to route to the website that you're looking for. And at the bottom level, it's going to be somewhere between, thinking of it as Ethernet. You don't see token ring used too much anymore. But Ethernet, which is how you are connected to the network that you're on, that then gets you out to the internet. So, so David, I hope that is what you were looking for in that question. Let's see. Well, you're very welcome to the person who thanked me for this being the best explanation of the OSI model they've ever gotten. Again, I can't take full credit. I had help with this, but where I do take credit is I've listened to people over the years, and I've listened to what people have said just confuses them, and what people have said really helps them get this. A few more questions, then we got to wrap this up. As far as the examples of ICMP and IGMP that you're asking for, IGMP, the only real example I can give is, again, multicast communications. Actually maintaining the list of multicast addresses, because there are specific multicast addresses that all recipients are assigned in a multicast transmission. So it has to do with the managing of those addresses. ICMP, the best example that is out there, and it's used all the time, is if you've ever heard of a tool called Ping. Ping, which is a very, very handy tool. When you ping an IP address, you ping a computer to see if you can get a response, that's using ICMP. That's what it's using to actually do that test. At which level does quality of service play a role? You know what? There is no one answer to that. That's a very good example of one that could be at multiple layers depending on the type of quality of service. A lot of thank yous. You're all very welcome. And looks like David is still looking for an explanation on FTP. Oh, and then he said thank you, so you're welcome. All right. Thank you, everyone. And real quick before I let you go, I just want to let you know that I hope this is not the last that I hear of you. I certainly don't want it to be. I know 3/4 of you said you'd never heard from me before. This is the first time. Wonderful. Hope to hear from you again. You can find me on Facebook. That's the best way to get in touch with me and to stay involved with what I'm doing. It's just facebook.com/TrainSignalEd. If you're struggling to find TrainSignalEd, just look me up by Ed Liberman. My personal Facebook page is also a public page, and from there you can either friend request me, and then I will send you a link to my the actual TrainSignalEd page. You can also follow me on Twitter. I don't do a ton on Twitter. That's why I apologize to whoever that was that sent me actually mentioned me in the OSI sausage pizza thing. I only noticed that today. I don't get onto Twitter that often. I mostly tweet based upon whatever I post on Facebook. You can also, and I don't know why that says TrainSignal Microsoft Learning, so we'll just leave it as TrainSignal by going to our blog. You can also go to Facebook /TrainSignal or Twitter /TrainSignal. And one last thing, and then I'm going to hand this back over to Chris and call it a day, is at the very bottom I have a link to a course that and for those of you that are already fans or whatever you call it on Facebook, there is a course that I just recently wrapped up called Microsoft Networking Fundamentals. This course is available with TrainSignal today. We've released this course today, and the link is there if you want to go get it. I will tell you that this presentation is a part of that course, and along with that, Chris mentioned at the very beginning that one of you is, if you go ahead and you're here and then you do the survey, is going to get a free copy of this course, and we will notify you by the end of business tomorrow if you are the winner of that course. But if you want to get the course anyway, it's about, I think it's a little over 8 hours of absolute networking fundamentals. It's a very 100 level, 100 to 200 level course. You can get it there.